Welcome everyone. It's probably first time in the last 3 years I actually see this big auditorium full of people willing to hear something I'm going to ramble about. I actually wrote a bit of script for this, but I'm bad with memories in those scripts, so it will be remembering as I go rather than citing something that I wrote about. So for the past maybe 10 years, a team I'm a member of, we are working on a bunch of stuff related to something that many people think is uninspiring because it's all about the enterprise use of Linux, which is just a done deal, right? Every enterprise uses Linux nowadays. And we kind of look into some of the areas and choose what to work on, because there's always stuff unfinished and needed to be worked on. And suddenly there's obviously 10, 15 years ago, some companies from the West Coast, they started to look into, hey, this shiny thing called internet and this shiny way of having your account somewhere in the social network drive your login into your machine and so on. And here we are 10, 15 years after talking about doing similar thing for Linux in enterprise environment and at home. So I will start with a bit of introduction. I'm working at Red Hat for almost 12 years now. I'm focusing on the identity management, so basically really running accounts in the Linux systems. Centralized identity management is what we do. Mostly working on these days free IPA, and I started with Samba 20 years ago. SSSD on the client side, MIT Kerberos for the authentication and so on. So there's a lot of things blended together, and it's really not a single person or a single project. It's an amalgamation of a lot of activities of a lot of people around the world. This talk is a kind of a split between past contemporary things and what we see in future, or what we see now will be in future, hopefully in Fedora 39, if we get this through in upstreams first and then manage to collect this all together in the distributions, which will be a point to talk about a bit later. But in the past, we've been always getting all this stuff kind of with a bunch of assumptions. So one of the really unspoken assumptions is that when you log into your system, be it Linux system or Windows system or so on, you don't only want to use that particular system. Typically, you want to go beyond that system. You want to go, well, in these days, you go onto web, typically, and use all these web applications, right? But before that, in office environment, you were reaching for your nice non-working printer, or you were reaching for something to fetch files from, or get the your home drive and all the other side stuff, or play games together with your colleagues on the local network and so on. And in many of those cases, you needed to try and get through the authentication information that you provided or got at the login time. So you needed to get this state of authentication translated or correlated into the network, onto the network services. And a typical approach that we see these days is that you unlock your, let's say, GNOME session. Then there is a secrets manager, which get your secrets store unlocked using the password that you provided as a part of login. Then the passwords from this secret store used transparently by the other applications through some common APIs, like browsers have their own stuff. Of course, they have their own password managers, and those might be even shareable across multiple devices and so on. But it still doesn't solve the real problem, which is when you log into the system and you go to specific network-facing applications, you need to do this transition, transfer the authentication state between maybe incompatible or not well connected protocols. It is bridging that we don't really have in place, and in many applications we kind of derive it based on certain things. Okay, it's in reality it's much easier in the enterprise world, because for almost 40 years we've been dealing with something that is called Kerberos, in different ways of it, which is effectively a decoupling of the initial authentication and then requesting some authentication tokens on behalf of you after you got this initial authentication done. And that's a nice thing. Over years, Kerberos as a mechanism grown these authentication, or how it's called awkwardly in the Kerberos world, pre-authentication mechanisms that allow you to use something more than just passwords. So you can use, for example, smart cards, or you can use one-time codes, two-factor authentication mechanisms, and so on, to log in or provide the initial credentials to obtain the so-called ticket granting ticket in the Kerberos thing. So the good part of it is that this is exactly a way to get the transferable authentication state. Over years, we added to Kerberos ability to record how this initial state was acquired. So an application can use an API to inquire whether this initial token was obtained with a password, or with a smart card, or with some other more strong type of authentication. So it can differentiate how to behave if, for example, application-specific policy says that you cannot use this application if you were not using smart cards, or you were not using FIDO2 tokens, and so on. Then application can inquire this information and say, yeah, you are not allowed to use this. You cannot use sudo on these machines because you merely used your password. That kind of thing. And this is the thing that I was doing a lot, and the one thing connected with this is that the complexity of a typical Kerberos environment is huge. But separating the pre-authentication method is a nice part, because it allows to decouple the other part of complexity, all these tokens or separate devices that you can use to prove who you are and that you possess these credentials, from the actual applications. It's really splitting up in these two parts is what is important here, because we can write applications once and forever, at least the verification of the authentication authorization there, and deal with the rest separately. Now this is, for example, how it looks like in a typical Kerberos environment with FreeAPA or with Samba AD or Microsoft's Active Directory. This is detailed description from the Red Hat's Enterprise Linux Identity Management Guide. Links are in the PDF, but just as an example of what we are dealing with. And the fun part is that, 7 years ago, I've been talking in the other room in Johnson about similar things, so how we started with this, how we started with the enterprise graphical workstations on Linux. That was, 15 Fedora releases in past. 15. That when I wrote that, I kind of did not realize that we are 37 now, and it's like seven and a half years back. And almost all this stuff already worked by that time. The smart cards were possible to use in this environment. Of course, there were some issues with the visual representation, how you choose these smart cards and so on, but it's kind of funny that what I will be showing to you today is kind of similar to what we did 7 years ago. We fixed this problem for smart cards eventually, together with the GNOME people, by introducing some interfaces between SSSD and GNOME components, the GDM and the other parts of the window manager, so that they can pick up this information and show a nicer UI to choose who you are based on your smart card and so on. But smart cards were the first thing we did with the with this passwordless authentication, because you don't need passwords anymore on this system. So what happened in these 7 years? And that's a nice period, because every 7 years something happens with people. They change themselves, and environment around them changes a lot, right? So what happened? Actually, there was change of winds, and a pretty fundamental one. If you remember 2015, 2016, a typical office environment, first there were offices where people were working every day, going into those offices, and they had a network actually where those computers were connected and enrolled into the whatever domain controllers were in those offices. So it really was an environment that was for the infrastructure for people, right? That you come, you switch in your laptop connected, and it knows what to do. It was so to say infrastructure for people. Nowadays, there's all infrastructure in cloud, and it's not for people, it's for applications. You deploy applications somewhere in the cloud, and all that infrastructure that is there is not for your you as an employee, you as someone who consumes it. You don't consume that infrastructure anymore, in most cases. Of course, there are exceptions. In most cases, you are consuming the applications, and applications consume that infrastructure. So if your laptop is enrolled in something, that's most likely not the same environment as your applications enrolled to. The applications are actually consuming what? They consuming stuff like OAuth. They get tokens, they get authorized to get tokens on your behalf from the identity provider service that is some vague stuff that you don't really know how is built inside in most cases, and you don't care. All you care about is that you can prove to this identity provider your identity. And for that, you can use a bunch of stuff. For most of the cases on the social networks or on a myriad of websites and so on, you don't even prove for them that you possess certain credentials. You prove this for some identity provider that they connected to. And that something that I call bring your own authentication. So you connect your account in something to your social network account. And you prove to the social network that you are who you are, and then that social network IDP issues token to that site where you want to be. That's essentially bring your own authentication to that site. The site doesn't really care how you authenticated to the social network, how you proved yourself. And in fact, what becomes out of it is all infrastructure around OAuth and OIDC as a part of it is built around, I have a browser, and this browser is everything I need. There are redirects between different components and websites. They talk to each other on your behalf. So this is kind of a new mainframe where everything runs, right? So you still need a network access for this to work. And here we get back to the 2016. In 2016, one of the biggest issues we were identified at that point for enterprise workers was that everyone goes into business trip, goes into the hotel, and every single hotel has captive portal on their Wi-Fi. So in order to log in onto your machine using your credentials, you have to solve a problem of solving captive portal before you log in into the machine. The fun part is that we never solved this problem at all. Instead of solving this problem, we basically say to ourselves, let's remove our machines from the corporate environment, right? Decouple machine from the environment rather than solving the problem. Maybe this is a good solution, but maybe not. Because right now, to get this authentication, again, working for us, we need to run browser before we log in again. And running browser before you log in entitles running insecure, unknown executable, which is JavaScript code, with the access to your hardware, which is your at least screen and GPU and so on, because that's what the browsers are requiring to do this stuff. So that's still the problem to solve. And of course, some of these problems might be solved, but some of these problems might be, hey, moved away. So almost everyone has a phone. So this is somewhere I can run a browser instead of my laptop. So maybe I can run the authentication and authorization process on this separate device instead of running it on my laptop when I try to log in. It's kind of getting around the problem, but maybe all the problems are like that. Get around them rather than solve them directly. And in some cases, this is not even a problem. For example, if you want to log in over SSH and you're already logged into your workstation, then launching a browser on your already logged in workstation is easy, right? You just need to have a URL to get into. So let's try. I hope I will show this. Let's try a demo. So here, I'm trying to SSH into some machine. And on the left side from you, I have a IDP based on the Keycloak open source project. And this user, it doesn't have the security key associated with it. Now I'm associating. So basically, I'm taking this kind of token and connecting with this user. Okay? I have this token associated somewhere there. And now I can log out of my IDP just to make sure that I don't reuse the same session that I obtained with the password, right? So now I'm trying to SSH, and I'm presented with a message that says, okay, authenticate against this browser somewhere. So I have a browser, it's handy. I'm using a security key to actually authenticate instead of the password. I authenticated into the system. Now the system says, you're authorized. Do you authorize this access? Yes, I authorized this access and logged into the system. But a part of this authorization is that I'm getting a Kerberos ticket. Kerberos ticket issued to me by my infrastructure. And now this Kerberos ticket can be used for, well, anything. Anything that's allowed there within this Kerberos environment. So I can SSH with this Kerberos ticket further. I can mount NFS or Samba or something shares, get access to files. I can use this Kerberos ticket to sudo into the system itself. There is, since last year, or actually 2001, there is a PAM module as a part of SSSD, PAM SSS GSS. This module actually checks that you have active Kerberos ticket and its properties are good enough to access PAM services. So you can configure, for example, sudo to say that if you have Kerberos, active Kerberos ticket, with obtain it with the this IDP authentication or smart card, then you can use sudo rules on this machine. Which rules is separate from this, but you can get access to sudo with it. You don't have password. You never had password in your system. And the password maybe existed somewhere in the IDP, in this keycloak thing, or in GitHub, or GitLab, or Google for your company, or Azure for your company, or your own, like keycloak stuff. But the rest will work the same, regardless how you get there. So it's a bit complex in terms of how this is implemented and how it goes. But at the core of it is we split the process in two parts. There's initiating part, which in this case is the running on the server I try to log in. There is a part that actually verifies that your IDP authorized access, which is running on the Kerberos key distribution center part, so Kerberos server side. And then there is a client, which is in our case SSH, trying to connect to the SSH server, which initiates process. And of course, there is a browser that you run somewhere. You saw, you're right there, probably to use a phone to access that URI, you probably want to have a QR code instead of the URI, or in addition to the URI. This is one easy kind of thing that we need to implement to make it easier, but also it will become probably a mandatory part if you want to integrate this with the graphical login into the system, because you cannot run browser yet, but sure you can show the nice picture that you can access from your phone or other device. And you will need something like that for the passkeys existing only on your phone, the soft FIDO2 tokens that both Apple and Google are eager to push to us these days. So effectively, the same thing works with the FIDO2. In fact, the demo that I showed was FIDO2 token, because the IDP side was configured to use FIDO2 or WebAuthn token instead of password or smart card or OTP, whatever is there. So we already can do this. It's already, in fact, all the tests that I ran, it's Fedora 37, the one that's already released last November last year. So this passwordless login to the Linux console works on Fedora, works on RHEL 8791, and a client side of it works on Ubuntu 22.10, because they have this new SSSD version that supports this stuff. Okay. So if I want to do this with the other services, let's hope I can get another demo. How I can switch to the next one, huh? Was it? Just a second. Okay, so this is basically exactly the same demo, just using, instead of SSH, I'm using vlog. Vlog is just a normal application that uses PAM, Pluggable Authentication Mechanism module, to lock your system. So typically, what happens is that you lock your console, and then you have to provide a password. Vlog doesn't know anything about all this stuff, but it works because we use the standard APIs there. And in this case, I don't need to provision the token, obviously, because it's already provisioned. But I can use it to log in into the vlog application. This goes just transparently, maybe awkwardly because of the URLs and not nice UIs and so on, but still, it's there. The most important part here is that in order to all this get working, we have to have a networking service, this IDP thingy. How we can get without it? Well, FIDO2 has this ability to work locally and not really through the web stuff. So we can run this authentication locally. And all these tokens that Ubico and, well, this is token EU or some others, they're usable in the isolated environment as well. So we can actually run it. So I got one small demo with this to, let's hope I get this starting. This is recorded with my phone camera because I needed to actually show you that I pressed something on the screen. So the screen is locked, right? And now I'm trying to log in into that screen. And it asks me to insert this passkey device. So I'm inserting it in, and you can see that it doesn't actually show you the full message that is shown there. The part of the message says, and press enter before it goes further. So when I press enter, it tries to communicate with the device. It blinks to me, and then I have to press attest that I am physically present at the device to log in it. And after that, I'm unlocking the same way as with vlog or SSH. Through the PAM, I'm unlocking this. This was my presentation this morning at the security dev room about the same thing. Now, if we go logically further, this is working actually, by the way. I cannot show it on this laptop because as soon as I lock my screen to unlock, the video stream through HDMI will get disconnected, and we will have to wait another 5 minutes to get my screen working back, so you wouldn't see this on the screen. So believe my camera. Now, how we can combine this? Okay, logging in locally with the FIDO2 token is effectively gives me a login into the system, but the very first thing, the same problem that I discussed in the beginning applies here. How I transfer this authentication state that I used this passwordless device to log in to other applications. Well, in enterprise environment, whatever we call enterprise environment, for me, for last 10 years or so, enterprise environment is my home environment because I run what I develop, free IPA, as my home authentication service. I simply need to transition from these FIDO2 token authentication to Kerberos ticket using it, right? Sounds simple. Yes, it's also a bit of arrows and lines and so on, but it's pretty much in line with this one. It's just a question of who is communicating with whom to prove that the possession of credentials is the real one. Okay. Unlike the previous one, I cannot show a demo of this one because we are at the point where maybe in 2 weeks we will complete this implementation. And of course, the amount of bugs to find and fix will get this probably delayed until Fedora 39 or so. But I really hope to get this working by that time, which is, by the way, just how many? 9 months away. Sounds a nice number, right? So that's not everything, of course, because, well, it's only the infrastructural part of it. To get it usable and not to the point that users will trash their laptops because they cannot read the message. Imagine this is just a simple insert your passkey device. What if this was authenticate against this URL, HTTPS, something that can't even fit into this box? That's the situation right now. So we need to fix this with, in this case, it's a GDM, of course. This is the GNOME display manager. For the login, we need to fix this. And we started talking with the GDM developers, and there's some common understanding what to do, similar to what we did with the smart cards. The nice part of it is that it's mostly about a protocol of communicating between the PAM service, in this case SSD, and the display manager through the environmental variables within the process. So SSD can tell that I'm now using this type of passwordless authentication. Please switch to this visualization of it. So we kind of can make it this way that it works for GNOME, but it's also usable for others. And here I come to the point of effort across multiple projects. So you can do this with the GNOME, but then what to do with KDE, what to do with XFAC and others. There's a need to agree on something. We can agree on APIs, we can agree on protocol driving semantics behind this, but somebody needs to implement all these pieces in the end. This is a common effort, us as a community. It's not just one company or one developer crazy enough can drive and write all this code and get it. We as a community need to work together to get this done. And of course, this is just a top of the iceberg. There's a bunch of work needs to be done on the distribution level to make it usable for clean installations, for example. If I want to use this type of the key, FIDO2 keys, for example, for the login into machine, I'm sure probably want to use it also to provision encryption of my disk. And this is already possible with systemd supporting configuration of locked devices with the FIDO2. In all contemporary distributions, systemd already compiled with support for FIDO2. It's a matter of configuring them, right? It's the matter of configuring other services to reuse all of this. But I don't think, as much as I like wiki pages that describe how to do this in multiple articles, I don't think this is what we should be doing. It's the distribution level job to polish or add this kind of polish. Again, as a community of distribution developers in Fedora, in Debian, in others, in Arc, we need to focus on this kind of polishing. When all these pieces ready, sure, someone will be faster with the releases and polishing of it, but in the end, we as a community, we as community of developers, users, we are users themselves, even if we know how this stuff works. It doesn't mean that we tolerate how badly it's integrated. So that's my message here. We need to work as a community to bring it all to us to be pleasant to work with. And with this one, I guess I'm even on time. Thank you.
My question is about the two-factor authentication when there is a password and a security key. Do you know why in all the workflow the password is asked first and then the security key, whereas it likes to me that the security key is the strongest part and it should be better to first press the button of the key and then enter the password? Is there some movement to change the current way of doing things?
The question is whether using password and second factor and so on can be one of the ways of doing it, and is there an activity to make it better, let's say this way? Yes and no. It depends on what we define as the first factor and second factor. One of the driving factors behind passwordless work in the last 10 years or so across the industry is the tightening of requirements from the governments, specifically from US government. US government issued so-called Zero Trust Memorandum last year urging governmental organization to move by end of fiscal year 2024 to move to passwordless authentication. This means that they have smart cards already, so that's solved. But they specifically name WebAuth and FIDO2 as one of the alternatives to smart cards. And in fact, all of these things, they have PIN associated with this, which can be looked as a kind of first factor. But it's not a first factor as we understand it. It's a first factor to unlock hardware rather than unlocking some factor in software. So this is the thing which drives some of this work, not necessarily for us, but for many others already. And I think there is a value in stacking factors. The question is in which environments you want to use them and so on, and configure this way. Certainly, there is already a mechanism to enable it. For example, PAM already is taken. So technically, you can stack multiple PAM authentication modules in the same configuration for VLOC or GDM or something, and say, always enter 3 passwords from different sources. That already would be multi-factor, multi-password authentication. Or one of them this, and the other one is the password, and the third one is face of the moon, and so on. So you can get that stuff already. It's the question of adopting to a specific environment where this makes sense. I have not seen multi-password in the traditional kind of environments yet. But if we do something like integration with the identity providers, like I show it in the demo, that gives you possibility to move this check away into, let's say, Keycloak. Keycloak actually has ability to ask a password, OTP, and the web auth at the same time. So you can configure that already. Yeah. Again, the question is in which direction you want to focus this. Maybe not adding into SSSD or some specific PAM module, but instead adding into more flexible and more controllable source. Okay. Any other questions?
Yes, here. So you were talking about how can distributions and desktop managers contribute to get like a unified interface. And I recently bumped into a project called XDG Credentials Portal, which tries to specify a standardized DBus interface for interacting with WebAuthn credentials, such that different KDE and GNOME and stuff can hook into this. I was wondering whether you were aware of this project and if that would be a good place to maybe start on trying to collaborate on a unified interface.
Yeah, so the question is, am I aware of the projects like XDG Credentials that tries to specify or unify access to the credentials for things like, I think it's for the containerized environments, desktop applications running in Flatpak and so on. And yes, I am aware, and that's one partial thing that I mentioned about the parallel effort there. But it's not for the login. It's for the reuse of the credentials in the browser or relaying party outside of the container so that you can isolate direct access. That's very important, but it's a bit different layer. And it's the layer that we will eventually need to reuse if we want to do this transferable state of authentication between different places without Kerberos. Yes, we will have to work with them, or they with us, or everyone. Yes.
Hello. So I use ED25519 security keys, which SSH supports. And it's really simple. So I just generate a key, and I can use it, and my SSH daemon supports it. And I don't really need to run any services. I don't need to use Kerberos. How do we get to a world where everything is that simple?
So the question is, why do I need all these things if my SSH keys work fine with the hardware-based tokens, X509-based certificates, and so on? The answer is simple. It's not an answer for all use cases. You cannot authenticate with these tokens and these keys to, for example, file services. You cannot use them to authenticate to NFS. You cannot use them to authenticate to SMB or other resources. Needs are different, use cases are different. All of this thing does not replace SSH keys, and SSH keys do not replace this one. They exist in parallel to each other, because if you start using FIDO2 tokens, you wouldn't be using them exactly the same way on SSH level as well, because SSH will need to generate their own keys based on the same use of the same hardware, but different protocol-specific and application-specific thing. And this is where the problem really comes in. You can find use cases where existing functionality is perfectly usable and secure and attainable, but it's not transferable to the other systems and other protocols. That's the problem we try to solve. So it's more amending rather than displacing.
Hello, and thanks for the talk. My question is, if I'm a very, very bad person and want to break this system and steal the Kerberos ticket authentication, for example, what's the easiest way I can do it?
So the question is how to steal Kerberos ticket in the Linux environment in the easiest way, despite all the protection mechanisms we want to add. I'd probably answer what mechanisms we have so that you may reconsider your activities. So in comparison, Microsoft some time ago added a virtualized slice where they store all the credentials, so you do not have access to that slice. It's running literally, not as a container, it's like a VM separated from the actual system, where they handle all the security credentials and so on. And you cannot easily store that from the memory of the applications that try to load this stuff. On Linux side, at that point, we had a project called GSS Proxy. The GSS Proxy is a daemon that runs in separate, typically under root, and it interjects into GSS API, hence the GSS Proxy, GSS API operations, and interposes access to all Kerberos crypto material. So when you, a service like HTTPD or NFS, you want to have access to the Kerberos key tab so that you can authenticate clients coming to you and get access to it. Or your IMAP or SendMail or something. And GSS Proxy basically removes access to the key tabs, removes access to credential cache that you use. They are in separate process. So now if you're broken into NFS server, like Ganesha or even the kernel, well, kernel one is probably easier target, right? If you happen to find a bug that allows to exploit it, but you're probably not a Linus Torvalds anymore, and it's not 1994 where he found NFS problems to hack into and get the data out of NFS. So typically this privilege separation between the processes works fairly well. If you're root, of course, you get what you get. In that case, there's some number of ways of preventing root running processes from accessing the capabilities on the kernel level, and on typically still this is an operation that should probably be multi-layered, like you have to use kernel capabilities, then you have to use the file system level capabilities, then SE-Linux or AppArmor to prevent other kind of access things. But basically with the GSS proxy, we get isolation on this level. And also we get the content of the credential caches encrypted. So you can store or you can steal credential cache if you get access to that, but it will be encrypted with a temporary key that exists only until GSS proxy runs. So even if you steal it, you cannot really use that one. The other part is that there are credential cache collection types that do not allow direct access to the credential caches. So for example, a keyring, kernel keyring, where you can store and tighten it fairly tight so that the application doesn't get these keys out. The other one is KCM, which is also a separate process accessible over the Unix domain socket. You don't get direct access to the files either. So there are some mechanisms. They are not so dramatic as in Windows case, where they run it in completely different VM, isolated on a hardware level. But we get fairly far away. I've seen people trying to decode the KCM databases, but that presumes that they get access to the physical root partition, so they can read the actual files from the KCM back store. But of course, that if you haven't access to the root partition, your game is lost in most cases. Yep.
Alexandra, many thanks for your interesting talk to give the community.
Thank you very much.